Okay, 4.3 representations of reactions. So I didn't print out an example for this, you know, those example papers I made, because it is the shortest section ever. And essentially we're combining 4.2, but you're also drawing it. And we have done drawings similar to these before, so it's gonna be like dang near review. And so when you're drawing, make sure to have keys to stuff. So if you're drawing something and you're using different shapes, make sure to show a key on what things are. And so here's my example I'm going to do. So here's 4 moles of methane, it's going to react with 4 moles of oxygen, and it's combusting. So what I want you to do first is write the balanced chemical equation. Alrighty, balanced reaction, boom. So now if we had to draw this, we got to think what would be in the container. Now, most likely all of these are gases because it's combusting. We don't know for certain. You could label the reactants and products as gases if you want to. I'm not going to, but you can if you want to. So we're going to do the before and after. We'll just pretend these beakers are closed. And so I have my key on the right side, as you see here. And so I'm going to go ahead and make my 4 moles of methane and 4 moles of oxygen gas. So, boom. Here we have our 4 moles and then 4 moles as represented by particles. So what I'm going to do is I'm going to make the products. So I notice I need 1 methane for every 2 oxygens. So I'm going to break apart this methane here and use these 2 oxygens here and these 2 because I'm using 2 moles worth for every 1 mole of this. So I'm going to break these down into these components. So I'm making 2 waters and 1 CO2. So here's my CO2 here, and then I made my 2 waters here and here. I'm going to do the same thing for the methane over here, and so I'm going to break that apart, and I made 2 waters and 1 CO2 again based off the balanced reactants, balanced reaction. And so I have 2 reactants left. I have my 2 methanes over here, and so I would draw them in. They are the excess reactant. So my limiting reactant was the oxygen. It limited the amount of product I can make, and I have excess reactant of methane. So you should be able to draw these. You can use different shapes if you want to. You can't use color on the AP test because there is no coloring allowed, no highlighters or anything. So just use different shapes if you need to. Again, these are non-ionic, so you don't write like charges or anything because these are all covalent compounds. Or, well, the oxygen isn't, it's just an element, but the rest are covalent compounds. Cool. So here's your turn. Try drawing this out. I have 2 ends here. So what kind of stuff is going to dissolve versus what kind of stuff is staying together? Because these are solutions, right? We have hydrochloric acid, we have our sodium carbonate in water solvent, so that's aqueous, and so they go through a double replacement. So you need to think who's dissolving completely in terms of product versus who's staying together. Draw the ions separately, so draw them in separate like circles, and then it'll be easier based off the hint A. So try this out, pause the video, and then I'm going to go with the answers now. This video is very short, so make sure that you actually try this before checking. So, balanced reaction and then drawing time. Here's our balanced reaction. Boom. I drew all of it. Well, I didn't draw it. Well, I did digitally. I drew it here. And so I have 4 moles of each. I separated the HCl because that's a strong acid, so the ions are separate. I have this aqueous, so they all are separate. There's 2 sodiums for every 1 carbonate, and so there it is. And so in the after, I have my sodium chloride. Those are not going to be together because they are soluble in water, so they're going to chill as ions. And then I have my weak acid. So H2CO3 is a weak acid, and so they stay together. And so that's why I have them together like this. They're touching. And then I would just draw this in like a beaker or something. Again, it depends on how the AP test wants you to do it, But here it is. I like to do it systematically just so I don't lose track, which is why I put them all very like in order. And then here I just copy and pasted and then changed a couple things. So be very careful about weak acids. Be very careful about strong acids. Be careful about weak and strong bases as well. And then don't forget the one rule you had to memorize in order to know what's soluble and not for our ionic compounds. Okay, bye!